What's up, mathematicians? Welcome to day 4 of At Home Learning. Today, I've separated this section into 2 days. So we're gonna do part 1 today, which is gonna be just multiplying and dividing radicals. So it's gonna be truly a great day to be a mathematician. Um, this says that the product rule says, just like we could take things apart whenever we were simplifying radicals, we can also put them together by multiplying the numbers together. Um, and then we're going to simplify, if possible, by looking for perfect squares that divide them. So we'll see what this looks like. First example, just multiply. What's 7 times 3? That's 21. And then you just got to look, is there a perfect square that divides 21? And the answer is no. So that one stays that way. Number 2, square root of 3 times square root of 3. That's 3 times 3, that's 9. Clearly the square root of 9 is just plain old 3. Square root of 3 times the square root of 15 is the square root of 45. Look at that. Is there a perfect square that divides 45? And yes, it is 9 times 5. So that simplifies to 3 square roots of 5. We're bumping it up a notch there. Number 4, you multiply corresponding parts, the outside and the inside. So 2 times 5 is going to be 10. The square root of 3 times the square root of 2 is the square root of 6, which does not simplify further. Number 5, added some variables in there. The square root of 12x to the 4th, right? Because remember, when you multiply, you add exponents. So 3 plus 1 gives you 4 for that exponent. Now we just need to simplify that. 12 simplifies to 4 times 3, and then the square root of x to the 4th, which is going to be 2, remainder 0, right? 4 divided by 2. The index is 2 on a square root. So that gives us 2, the square root of 4, and then this is an x squared, no remainders, so there's none of those left in there, which means there's just the square root of 3 left inside of the radical. Simple enough. Number 6, we're squaring it, so you square each thing individually. So it's going to be 3 squared, and then the square root of 2 squared as well. So 3 squared is 9. What's the square root of 2 squared? Well, I mean, you can think of it like this. The square root of 2 times the square root of 2 is the square root of 4. But what's the square root of 4? It's 2. So really, square rooting and squaring are opposites. They cancel each other out. So the square root of 2 squared is 2, which means we have 9 times plain old 2, which is 18. So similarly, number 7 here, it's going to be 2 squared and the square root of 7 squared. So that's going to be 4 times 7, 28. On 8 and 9, looks like we've got cube roots. Same thing, you just multiply 4 times 18, which is 72. You got to look for a perfect cube that divides it, and it's going to be 8 times 9. And the cube root of 8 is 2, so it's going to be 2 cube roots of 9. Number 9, same thing. That's going to be the cube root of 500. The cube root that divides 500 is 125 times 4. And that's going to be 5 cube roots of 4 when you simplify it. The next couple of lines we're going to add in parentheses. So same, it's no big deal. Just distribute. So the square root of 5 times the square root of 5 is 5 because it's the square root of 25, and then minus the square root of 10, which does not simplify. All right, number 11 here, we'll distribute as well. 3x times x is 3x squared. And then that times itself, the 5 would still be on the outside. 3 times 3x is going to be 9x. So this one's going to be a little more complicated to simplify. If we think of this one as the square root of 3 times the square root of x squared, the square root of x squared is going to be x, so that's x squared roots of 3 in the correct order. That one we have the square root of 9 and the square root of x. The square root of 9 is 3, so 5 times 3 gives us 15 square roots of x. Those don't go together, so that's as far as that one will go. Number 12, we're going to FOIL that. So we're going to first distribute the square root of x. So that's going to be the square root of 3x. The square root of x times the negative square root of 2 is going to be the square root of 2x. Then distribute the square root of 2 through. That's going to be the square root of 6. And the square root of 2 times the square root of 2 is minus 4. None of those are like terms. These are not like terms. Remember, the radicand itself has to be the same in order to put them together. So that's as far as that one will go. None of those can simplify any further either. So if you want to try 13 and 14, that would be a good time to pause the video and see how you do. Otherwise, I'll go ahead and do them and you can follow along too. The square root of 5 times the square root of 5 is 5, because that's the square root of 25, but that's just 5, so I don't even write the square root of 25. That's going to be plus 7 square roots of 5. This one will be minus 7 square roots of 5. This one, of course, minus 49. So a positive 7 square roots of 5 minus 7 square roots of 5, those are going to cancel each other out. And 5 minus 49 is going to be negative 44 for an answer there. 14, remember what it means to square something. It means to multiply it by itself. So it's going to be the square root of 7x plus 2 times the square root of 7x plus 2. So that's got to be FOILed out. What's the square root of 7x times the square root of 7x? Remember, something times itself in the radical is just going to be what's underneath the radical, so 7x. The square root of 7x times 2 is 2 square roots of 7x. 2 times the square root of 7x is, again, 2 square roots of 7x. And then 2 times 2 is 4. So those middle two terms will go together. I'm going to move this 4 out to the front. I'm going to do 7x plus 4, and then I'm going to put those radicals together. I think they should go last. So that's going to be 2 square roots of 7x plus 2 more square roots of 7x is going to be a total of 4 square roots of 7x. Remember, when combining things, the radical does not change. You just do what the coefficients say. And that can't reduce any further, so that's going to be our answer there. Let's flip it over to the back. We've got a few division problems. Remember, just like before, if we can separate it into 2 radicals, we can put it over a single radical and do the division. It's going to make your life a lot easier to simplify it that way. So we're going to say this is the same as the square root of 14 divided by 2. Well, what's 14 divided by 2? It's 7. So that's the square root of 7. Can't go any further. This one is the same as the square root of 100 divided by 5. 100 divided by 5 is 20. And then that one will simplify further. 20 is the same as 4 times 5, so it's going to be 2 square roots of 5. Number 3, again, put it over a single radical, 12x cubed divided by 3x. So 12 divided by 3 is 4. X cubed over x to the first. Remember, move the smaller one and it changes the sign, so we'll be subtracting that exponent. Is 4x squared. So the square root of 4x squared, square root of 4 is 2. The square root of x squared is x. So that one just simplifies to 2x. We can do them with cubes as well. It's the cube root of 625 divided by 5. 625 divided by 5 is 125. So it's the cube root of 125, which you hopefully know by now is 5. Next one, cube root of 32 divided by 4. 32 divided by 4 is 8, so the cube root of 8, which is 2. So not too difficult today. You'll have an assignment over these first part on my math lab. Do that. Tomorrow you'll see the second half of the section. And good luck. If you need any help, please reach out. Don't be a stranger. See you later.